Hi, I'm Flavio, and this is an introduction to predictive maintenance. The topic of predictive maintenance has been thrown around a lot in recent years. It represents the very appealing idea where we can determine when maintenance should be performed on some system. This is in contrast with what we call preventive maintenance, where routine or time-based checks are performed regardless of whether any intervention is actually needed. Think about your car. You get your car serviced every year or every 10,000 kilometers, regardless of whether you actually need to change your oil filter or the air filter or any other component. With predictive maintenance, you'd be advised to change those parts only when actually needed. So there are two main approaches to predictive maintenance, either model-based or data-driven. In model-based predictive maintenance, we build a physical model of some system and we use that model to infer the system's degradation. This typically produces very accurate results, but it requires building a separate model for each part of the system, which is typically very expensive and also quite complex. On the other hand, we have data-driven predictive maintenance. In this case, we make predictions on the state of a system only based on data that has been collected from the system itself. So we do not require building a physical model of the system, and since collecting data is becoming cheaper, it is also a fairly inexpensive operation. So why do we need predictive maintenance? Typically, with predictive maintenance, we will save money, since we will only perform maintenance operations when they are actually needed. This means that we will not perform operations that are not necessary when the system would be fine anyway, and we will not ignore situations that could lead to a higher damage fault later in the future, because we will be able to detect that. Obviously, if we apply those maintenance operations to our products, we will propagate the benefits to our customers as well. And then finally, and this is a nice side effect we discovered, when we build a predictive maintenance model, we get to interact with domain experts, so we can provide them with feedback and with some data-driven insights, which has proven to be very useful to them. So now, with the time that I have left, I will tell you a little bit more about a use case of predictive maintenance in the automotive industry. In particular, we collaborated with General Motors on what we called the oxygen sensor clogging problem. And as you can guess from the name, the oxygen sensor is a sensor which measures the concentration of oxygen in the exhaust gases. And the problem with this sensor is that after a while it gets clogged because it is constantly exposed to particles contained in the exhaust gases. Now, when this sensor gets clogged, it provides slower and less accurate measurements, resulting in a less efficient combustion, with everything that comes with it. More pollution, more fuel consumption, and overall a worse driving experience. So the domain experts provided us with data collected from various sensors displaced around the engine, and we approached this problem as a classification one. So starting from the sensor data, we wanted to classify whether the oxygen sensor was in good health, or in a degrading situation, or in poor health. If we're able to do that, we can then recommend servicing the car when the sensor is starting to deteriorate. We used a very extensive data preprocessing pipeline where we started from the raw signals collected from the engine, we discarded redundant information, and then we extracted representative features from the signals. We then accounted from some temporal relationships contained within the data, and we built models based on state-of-the-art classifiers, such as neural networks or random forests. Now, this was a preliminary work, and some more effort will be required to bring all of this to production. But we obtained very promising results, and that led to publications to both journals and conferences, as well as a patent being filed by General Motors on this very methodology. So hopefully I have given you an overview of what predictive maintenance is, why it is useful for both manufacturers and customers, and what a use case in the automotive industry looks like. So thank you all for watching, and hopefully I will see you all soon. Bye!